We present a system that composites a realistic picture from a user-provided sketch with text labels. The composited picture is generated by seamlessly stitching a background and several foreground items from photographs retrieved from the internet in accordance with the sketch and text labels. The user interface of our system is intuitive. A rectangle represents the background. The user indicates some scene items and their locations in this rectangle. By default, each item is represented by a circle, but the user may optionally sketch a shape outline instead. Each item is given a text label, which is later used for search. The background is also given a text label. Once the composition has been determined, the system searches for elements to make up the picture. Web searches often generate incorrect and unwanted results. We use a filtering scheme to select images amongst these noisy searched results. Background images are filtered by clustering and discarding unusual ones. Scene items are filtered in a similar way and also by taking into account the sketched shape contour. This filtering provides a set of candidates for each scene item and the background for use in compositing a new picture. We evaluate how well these candidate scene items and backgrounds match and select several optimal backgrounds and corresponding sets of items which lead to high-quality final output. These outputs are shown to the user, from which the user selects the most pleasing result. In our system, some steps are performed with standard methods. We briefly illustrate those steps containing our new ideas. A novel filtering scheme is used to process results from an internet image search, which typically includes many inappropriate responses. Salient region detection gives an approximate boundary for scene items. This boundary is then refined using the grab-cut algorithm. Shape matching is used to discard inappropriate matches. Feature space clustering is used to reject many inappropriate scene items or backgrounds returned by search. This filtering approach lets us rank matches according to the user's requirements. To efficiently evaluate whether a scene item may be suitably composited with a given background, we divide the compositing area into superpixels and compute a composition cost which takes into account texture similarity, color similarity, and feasibility for alpha matte extraction. This cost is used to select an optimal subset of images for compositing the final output. The output image is synthesized using a novel gradient domain composition algorithm, which has the advantages of both Poisson image blending and alpha blending when given a large set of candidate images for selection. Further details are given in our paper.